eclipse here in North Carolina, we'll see 85% of it, according to what our the meteorologists have been stating. So I'm excited about it. However, once I'm done here, I'll be out in the neighborhood doing STEM education. Some of you guys catch me from time to time going live, whenever I'm out in the community. And so that's what I'm going to be doing today. I'll be out going live also. Okay, so guys, what we're going to do today, we're going to go ahead and switch the screen because, it's time for us to go ahead and get started in our lesson. And I've received so many different requests, and I've been trying to get to each of you guys' requests for chemistry. So in case you want to know when I go live typically Monday through Thursday, 12 noon Eastern Standard Time. So that's, the time that I go live. I've been going live every Monday, Tuesday, Wednesday, Thursday since the semester started back in January. So I know that we're getting to certain parts of chemistry that are very, let's say, challenging, but you don't have to fret. You don't have to feel like you're alone. If you just give me the questions that you have concerns about, let me know what you need help on. I'll try my best to get with you during my lives. However, if you need more one-on-one, by all means, click the link in my bio and I can get you straight that way as well. So I know many of you guys are in chemistry right now and you want to pull your hair out, what hair you got left. If you've been pulling it out all semester long, you don't have to feel like this is the end. However, if you stayed with your chemistry class this far, guess what? You're a real one. You're a real one. Yes, I know, March Revolution, those titration labs were the worst. I was telling someone the other day how with the titration labs, if we wanted to rush, we had to count literally every drop of base that we added to our Erlenmeyer flask. And if we wanted to rush through it because we wanted to go hang out on the yard, then what ended up happening was we over titrated it and our results would be wrong. And then we would get it marked off, like a lot of points. So yes, we had to take our time to do that. Well, Leah, I will do that one later on with hybridization and bond order, because today I'm now getting to students who've had the request for molarity and titrations, but I can try my best to get to your question by Wednesday or Thursday. Kathy, I did do videos on enthalpy. So if you need help on enthalpy, you can go watch out some of my other videos that I have on my page on TikTok and on my YouTube channel. My YouTube channel is Learn Chemistry with Professor TK the Chemist. Learn Chemistry with Professor TK the Chemist. You're welcome. But you can also hit the link in my bio and it'll take you straight to my YouTube channel. So you can see the office hours. It's listed under office hours with enthalpy, and then you'll be able to get straight to some of your questions. Hello, Dr. Berry. How you doing today? And let's see, Deasia said, do you have any advice for chemistry labs in general? Well, it depends. It depends. A lot of times your professors will have you guys doing your labs with a lab partner, and then you guys got to collect the data together. The biggest thing is to read the lab before coming to class. Read the lab before coming to class, because otherwise you will end up with what? Confusion. And some professors get a little irritated and annoyed if you ask them a lot of questions and it appears as though you did not read the lab. Yeah. I would recommend that you read the lab in general before coming to class and answer those pre-lab questions depending on what your professors are having you do. Some professors are different in terms of what they expect. Those are just some quick little tips I would recommend. Now, for today's lesson, we're going to go ahead and get started. I appreciate many of you guys for stopping in and coming through on our lesson today, because we're going to actually go through titrations and molarity. And I know a lot of times when we deal with these types of questions, we have to know which formulas to use. So I do have a few of them up here on the screen that you guys can actually look at and keep track of, so you'll know what you've got to do when it comes to molarity problems. So I'm going to highlight the different formulas that we have. The base one is, of course, the main one, the main star of this is M equals moles per liter. Now, here's something else that you can derive from that. If you want to get the volume, you could also say, okay, volume is equal to moles per molarity. And then if you're trying to get, let's say, the moles, okay, that's moles is equal to molarity times liters. Now, these are like your three main formulas, but there's also the other one that I would consider to be like an expanded version. And this is M1 times V1 equals M2 times V2. So that means you'll be given three of those variables, and you're going to have to find the other one, okay? So they may ask you to find the molarity of an acid concentration, or they may ask you to find the volume of a base concentration. It just depends. So I should have probably put, well, I could actually say M1 times V1, but I can also say, let me make a note here, okay? So that way you guys will know. I could say the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. So that's how I can use those two as well interchangeably, okay? So depending on how you're reading your problem, that determines what formula or the way you would actually write your formula out, okay? So for those of you guys that may have trouble solving for molarity, we're going to do just, one or two problems so that you guys can actually know how to solve molarity, okay? And it really depends on what they're giving you in order for you to do it. So if I say, all right, let me just give you an example, okay? Because that's the thing, you want to know exactly how to do a molarity problem, especially when these types of examples are going to come up quite often, okay? They're going to come up quite often. So if I were to say, find the molarity of a solution, okay? And let's say that, and I'm just going to give you some information here. That way you guys can kind of see what I'm talking about, okay? It says, what is the molarity? So I'm going to put M equals as a question mark of a solution prepared by dissolving 37.94 grams of potassium hydroxide in some water and then diluting the solution to a volume, okay, of 500 milliliters, okay? So this is what you were given right here. So you were given the volume, yes. You were given grams, yes, but grams must be converted to a mole, okay? So if we know that the formula is equal to M is equal to moles per liter, then what you're going to have to do is take the grams that they gave you, okay, and multiply that times, or, well, not actually multiply, you're going to divide that by the molar mass of this particular compound, okay? So you're going to have to take the grams that they gave you and convert that to a mole, okay, in order to use this formula right here. So what's associated with moles, of course, are the grams. So we would have to find the molarity of potassium hydroxide, the molar mass of potassium hydroxide. So the molar mass of potassium hydroxide, if you look at your periodic table, potassium has a molecular weight of 39.10, okay? This is just a quick way to do the problem. 39.10 plus 16.00 grams per mole for oxygen plus 1.008 grams per mole for hydrogen. So all you're going to do is add those together, okay? 39.10 plus 16.0 plus 1.008. And I get 56.11, okay? 56.11 grams per mole. So what I'm going to do is show you guys from top to bottom how to utilize this problem when you're solving for molarity, okay? It's not that difficult at all, but you do have to know some key factors when it comes to solving these types of problems, okay? So if I give you grams, and I give you milliliters. First thing you're going to also have to do is make sure that your volume is in liters, okay? Because all I've given you so far are grams that has to be converted to a mole and milliliters that has to be converted to a liter, okay? So what I'm going to do here is show you guys step by step how to solve this type of problem, okay? Again, this is our formula that's highlighted in purple. Now, first thing I'm going to need to do is take the 37.94 grams of potassium hydroxide. And on the very top, I'm going to put 1 mole of KOH. And on the very bottom, the 56.11 grams of KOH. And again, that's the molar mass conversion that you're using, okay? So now all you're going to do is get rid of your grams, slash those out, and then divide, okay? So I'm going to say 37.94 divided by 56.11, okay? And we get 0.6762 because we only need 4 of those significant digits. So 0.6762 moles of KOH. That is the top number that I can use, okay, for this particular problem. Now, on the next one, to convert milliliters to liters, all you're going to do is move your decimal back 3 places to the left. That's 1, 2, and 3. So you end up with 0.500 liters, okay? So, guys, all we're going to do now is plug our formula here. Molarity is equal to moles per liter. And we just solved for the moles of 0.6762. And on the very bottom, 0.500 liters. So we only need 3 of those significant digits when we actually calculate this out, okay? So 0.6762 divided by 0.500 gives us 1.35. 1.35 big M for molarity. And that is our final answer for finding molarity. Okay, that's all you have to do when it comes to molarity. Now, the reason why I'm going through, thank you. Now, the reason why I'm going through these problems like this is because for some of you all, if I were to go straight to a molarity problem and you didn't know how to calculate molarity, this will become an issue. This will be problematic. Why? Because let me tell you, some of your teachers, like I said before, can become very impatient when you don't get certain precepts in order to do the problem. So you want to make sure that you know how to do this before we even get to that. Okay? So I wanted to go through a pre-problem to get straight to what we need to know. Again, in case you guys missed it, okay? In case you missed it, when it comes to molarity problems, molarity and titration problems, what you have to remember here is that molarity is equal to moles per liters. Volume, if I ask you to find the volume, it's moles divided by molarity. If I ask you to find the moles, I must give you molarity in liters. However, there will come a time where you're dealing with acids and bases mixed together, and you're going to have to find your answer, utilizing the formulas that I have highlighted in purple. But you got to know the foundation, which is the one that's highlighted in yellow, in order to do the one that's in purple. Okay? So let's go ahead and get into a problem utilizing those formulas, particularly the ones that are highlighted in purple. Now, here is the deal, okay? When it comes to problems like what I've just showed you all, I always tell you guys, okay, and I've been saying this for as long as I've been teaching, always keep your formulas on note cards, okay? So that it's easier for you guys to process the information. You want to have what I call note card chemistry, so that you can keep up with your formulas for each chapter that you're working with. And it's easier for you to go and pull these note cards so that you're able to solve the problems without trying to go through all of your notes. You want to kind of condense your notes into small bite-sized pieces of information. Now, yes, I have the answers here because I want you guys to actually see how to solve these problems. When it comes to molarity, your volume should be in liters. However, if your milliliters in this particular case are canceling out, then that part doesn't matter per se, okay? Just a little FYI. So for instance, if I am asking you for like letter A right here, where it says you're going to use the table to find the information, they have given you M1, V1, and V2. You're looking for M2, okay? You're looking for this one right here. So what you're going to have to do to solve this problem, okay? Because you're looking for M2, we're going to use this formula right here, the base formula right here where it says M1 times V1 equals M2 times V2. You can use that formula to solve it. Now, since we're looking for M2, let me show you guys the formula for that one, okay? So M2 is going to be M1 times V1 over V2. So in this particular case, okay, when it comes to molarity problems, all you need to do is, whenever you hear the word of, that means to multiply. So that means I'm going to basically multiply the two columns that are together and then divide by what's left over, okay? It's just that simple. So if I give you, like in this example here, if I give you these two together, they're together, I'm going to multiply these two and then divide by what's left over, okay? That's simple. So let's see how easy that can be. So 0.500 times 20, and then divide that by 100, and you get 0.1. But remember, you must have three significant digits, and that's why our answer is 0.100 molarity right here, okay? So again, when you're reading problems of this degree, and I'm telling you to find the other missing piece, the two that are side by side, or if you read a word problem and it says of means to multiply, okay? So in this next example right here, all I'm going to do, these should be quick problems that you should do. You're going to multiply these two together and then divide by what's left over. So whatever I'm circling, that's the division part. So again, 0.075 times 500, 0.00 divided by 1. And again, you should have three significant digits. And I know that in this answer here, I'm sorry, two significant digits, because you have two significant digits with the 0.075. So although our calculator gave us 37.5, you must round that off to two significant digits. And that's where the 38 milliliters comes from. Okay, so these types of problems are literally that simple. Okay, they're literally that simple. So again, the two columns that are side by side with given information, all you have to do is multiply them and then divide by what's left over. That's all. That's it. Nothing to it but to do it. Okay. Now, problems like this, yeah, they're easy when they're in a chart form, but what happens if you're trying to do it in a word problem? Can you do the same thing? Yes, you can. Yes, you can. So let me give you all a problem of that nature so that we can see how simple this problem can be, okay? So let me find one. Hey, Karen, thank you. Thank you so much. So let me give you guys a problem that you can do when it's in word problem, okay? And you're having to solve for the unknown, okay? So again, matter of fact, this is a good one right here. Sample problem 1, okay? So I'm going to cut that one out, and I'm actually going to paste it right here so we can actually utilize the space on the screen, okay? So here we go. It says, what is the molarity of a solution that is made by diluting 500, excuse me, I need my glasses on, made by diluting 50.0 milliliters of a 4.74 molarity solution of HCl to 250.00 milliliters. Okay, so I know that was like a mouthful, right? And you're like, okay, so what am I supposed to do with that? Well, here's what you've got right here, okay? What you're going to do, you are going to look at what they gave you. Again, you know it's M1 times V1 equals M2 times V2. Okay, so let's look at the problem again. They said, what is the molarity of a solution that is made by diluting 50.0 milliliters of a 4.74 molarity solution of HCl? So we can say that these two numbers right here are M1, V1, okay? So we can say 50.0 milliliters times 4.74 molarity. When you see the keyword of, that means to multiply those two. Now, it says to a 250.00 milliliter, okay? So that number right there that I'm going to underline in red, that's going to go on the very bottom. That is going to be your V2, okay? The 250.00 milliliters. Of course, your mLs are going to go away. Your final answer should be in 3 significant digits. Micah put 0.948. Let's see if you are correct, okay? Let's see if you are correct. So you've got 50 times 4.74. Then divide that by 250. And Micah, we check out together and you are correct. So your molarity is equal to 0.948 M for molarity. Very good, Micah. Thank you for checking that. Okay. So these problems, again, when they're word problems, it doesn't matter. It doesn't matter if they're word problems or if they're in a chart form. The processes still work the same, okay? The processes still work the same. So now let's do another one, but this time, let's look for something different, okay? Here it says, what volume of water would you add to 15.00 milliliters of a 6.77 molarity solution of nitric acid in order to get 1.50 molarity solution? Now, here's the thing. When you read word problems, you've got to read them and make sure that what you are reading is what you're solving. There are some key things here that you need to do. Okay, so here's what they told you. It says, what volume of water would you add? Keyword is add to 15.00 milliliters of a 6.7 molarity solution of nitric acid in order to get, 1.50 molarity solution. Okay, so they're giving you key pieces of information in this problem. Again, I'm going to go back to my M1 times V1 equals M2 times V2, okay? We're going to use that formula, but look, remember how I said, if they give you an of, that means you're going to multiply those, right? You're actually going to be looking for V2 because they're asking for the volume. So your M1 times V1 is right here. And let me go ahead and put this down so you guys can see this, okay? So we're looking for V2. So I'm going to take that 15.00 milliliters times 6.77 molarity divided by, okay? I'm going to divide that by the 1.50 molarity solution. Now, of course, the M's are going to cancel out, but here is the trick, okay? Here is the trick. You got to be very careful when you read the problem. So watch this. I'm going to take that 15.00 times 6.77, divide that by 1.50. Now we get right here 67.7 milliliters, okay? But that is not our answer. It says, what volume of water would you add to 15.00 milliliters of a 6.77 molarity solution of nitric acid in order to get a 1.50 molarity solution? So what you would have to do is take that 67.7 that you just got, and you're going to say basically V2 minus V1 equals, okay? And that's going to give you the volume of water that was added to dilute it, okay? So that's the volume of water added to dilute, okay? Oops, you didn't see that part. Sorry, guys, okay? So what you got to do right there, okay? Let me, whoops. Hold on, guys. Let me scoop this off so I can get to this part right here, okay? So you're going to take this part right here that I'm going to highlight, if I can highlight it. There we go, okay? So you're going to take the V2 minus V1, and that's equal to the volume of water that was diluted. So that 67.7 milliliters that we just found minus what initially was in there, the 15.00 milliliters, that is our answer, the final volume. So 67.7 minus 15.00 gives us 52.7 milliliters. Reading is fundamental in chemistry. When you're dealing with these word problems, reading is fundamental, okay? So that is your answer right there. That is the volume of water you're going to add to make the dilute solution, okay? Hey, Sydney. Hey, Kathleen. Kathleen, I'm sorry. Thank you, guys. Thank you, Malcolm. So I appreciate all the shares and the follows. Yes, thank you guys so much. And I tell students all the time, like, for those of you all that are hopping on, I go live Monday through Thursday, Eastern Standard Time. And I know that several of you guys have asked me to do titration problems and word problems of this nature that deal with molarity and volume. And so that's what I'm doing now. But I also want you guys to be aware of the fact that when it comes to these types of problems, you do not have to overthink them, okay? You do not have to overthink them. So let's do one more similar to what we just talked about right here, okay? Let's do this one right here. So I'm going to go ahead and, again, highlight what they gave us in the problem. So let's put this in pink this time. What volume of water, so we're looking for the volume of water, okay, it doesn't like pink. Let's stick to the yellow. What volume of water would be added to 16.5 milliliters of a 0.0813 molarity solution of sodium borate in order to get a 0.0200 molarity solution? Okay, here's what we're going to do. We're going to set it up, okay? M1 times V1 equals M2 times V2. Kathleen, nomenclature. Well, I do have a couple of those problems on my site already. You can go to my YouTube channel, but you can also get some of those videos right here on TikTok as well. And if you want to, if you need something further than what you see, go on my last video, type your question so that I can remember to do your problem so that I don't forget. Okay, you're welcome. You are so welcome. So this is our formula here. M1 times V1 equals M2 times V2. So what you're going to do, remember when I told you, if you see the word of, that means you're going to multiply those together, okay? So in this particular case, the 16.5 milliliters are going to be multiplied together. And that's your M1 times your V1. And I put the numbers in the backwards way with the formula, but you'll see here that they're going to pretty much cancel out anyway. Again, your milliliters is your volume and your molarity is the M. Now you're going to divide that by the number that's left over right here, the 0.0200 molarity. Well, Aaron, okay, thank you so much for your question. Do you have videos on titration problems for General Chem 2? What specific help do you need with General Chem 2 with titration? I do have a couple of problems on my YouTube channel, and even including this one right here, that could also help. I will be getting into some more titration problems in a second, though, after I do this one. So now your M's have canceled out and you're looking for your volume, okay? So again, we're just gonna type this in and say 16.5 times 0.0813 divided by 0.0200. And again, we only need 3 of those numbers. So that's 67.1 milliliters. Now remember, that 67.1 milliliters is not the final answer, because remember, we've got to do what? We've got to subtract that from what was added, that 16.5. So your answer is going to be V2 minus V1. That's equal to the volume of water that was added to dilute, okay? That's the volume of water that was added to dilute. So let me go ahead and plug that in, okay? And so you're going to get 67.1 minus the 16.5, okay? So 67.1 minus 16.5. Hey, Kiara, I've got some videos on that right now on YouTube. I'm currently not working on stoichiometry modes to modes right now, but I tell you what you can do. Put that on my last video, and I can see if I can go back over that one for you, okay? 67.1 minus 16.5 gives us 50.6 milliliters. And as you guys can see right here, okay, we go back up, that's the answer right there, 50.6. Okay, Jocelyn, I got you. I got you. Yeah, so for those of you all that are needing help with stoichiometry, with moles to moles, I do have several of those videos on TikTok right now as we speak, and also on my YouTube channel. But if you want me to do those problems, put that on my last video, and I can go live tomorrow and do one of those for you, okay? All right, so this is our answer, and the two answers match up, 50.6 milliliters, okay? You're welcome, Jocelyn. Now, I'm going to show you all another problem. This time it's a titration problem, okay? So titration problems can be a little like interesting depending on what you're working with, okay? So let me go ahead and do this. I'm going to go ahead and actually show you all how to do this particular problem so that you guys will know exactly what to do when it comes to titration problems, because they're a little bit more in detail. And those, ladies and gentlemen, require what? You say it's hard? No, it's not, Aaron. Don't be telling that tale. Oh. Anytime you see a titration problem, just know that you need to do what? Have a balanced reaction, okay? So this is kind of along the lines of the stoichiometry folks' questions, okay? So you will need to have a balanced reaction. So in this particular case right here, I'm going to read it out, okay? Hey, Sammy, how are you? Okay, it says in a titration, 27.4 milliliters of 0.0154 molarity of barium hydroxide is added to a 20.0 milliliter sample of HCl of an unknown concentration. Hint, hint, you're looking for the concentration. What is the molarity of the acid solution? Now, here is the deal. Hey, Riri, what you got to do in this problem, because they're telling you that this is a titration problem, you're going to have to set this up, okay, using a balanced equation. Okay, using a balanced equation. So let me show you what that is. They just told you that barium hydroxide is added to HCl, hydrochloric acid. You're going to end up with barium chloride, okay, plus water. And I'm just going to go ahead and balance this problem out. I'm not going to show you how to balance it because by now you should actually know how to balance your formulas, and because of time also, okay, because of time. We got one barium on the left, one barium on the right. We've got two oxygens on the left, and we've got two oxygens now on the right. For our hydrogens, we've got 4 total right here because of the 2 plus the 2 here that gives us 4. And then the 2 times 2 right here gives us 4. Yes, Aaron, I actually did the ice chart about 3 weeks ago. About 3 weeks ago. So now, what are we going to do next? Okay, keep this in mind. What did they give us together? They gave us the value for the base part together. 27.4 milliliters of 0.0154. Since those two are together, you can actually do what? You can use those two, okay, to multiply together. Okay, if you remember the formula, M1 times V1 equals M2 times V2. That's, again, the same thing as the molarity of your acid times the volume of your acid equals the molarity of your base times the volume of your base. So since we're dealing with acids and bases in this particular problem, they did give me the base part, but they did not. They gave me 2 things for the base, but they only gave me 1 for the acid. So I know that I'm going to use this side over here, the MB times VB, okay? So the molarity was 0. And let me show you, I'm going to highlight, this is the formula that we're going to use right here. 0.0154 molarity times the volume, 27.4 milliliters, okay? We're going to divide that by the 20 milliliters, okay? But before we do that, let's first get the base, because this is actually going to give you some key pieces of information that you need to know here in order to solve this problem, okay? So for this particular problem right here, okay, Giselle said, what are the acids and what are the bases? Okay, so let's identify those again. Barium hydroxide, okay, is your base. So let me write that over here, okay? Barium hydroxide is your base, okay? That is your base. And your acid, okay? Your acid is the HCl. And the only thing that they gave you for the acid is the 20.0 milliliters, okay? Now, in order to do this problem, I'm going to have to convert the 27.4 milliliters to a liter in order for me to get this part right here, okay? The reason why we're having to do these different steps is because we need to put and utilize our coefficients within these problems, okay? We got to utilize our coefficients within the problem for the acids and the bases. Now, I'm going to rewrite this. I'm going to keep this 0.0154. I'm going to write this as moles per liter. And now, I'm going to convert the 27.4 milliliters to a liter by simply moving my decimal 3 places back to the left, or you can just divide by 1,000, okay? Either way it goes. I'm going to cancel out my liters, and now here I'm left with moles. And again, this is for the barium hydroxide. And I'm so glad that you asked that question, Giselle, because that's going to actually help you for this part right here, okay? So what we're doing is we're getting the moles of our base, because we're going to use that to get the moles of our volume in order to give the molarity formula, okay? So right here, let me go ahead and plug this in. Okay, Bree, you said you're working on this right now. Okay. 0.01. If you're confused, you got the right video to watch. 0.0154 times 0.0274 gives us, now this is a very small number right here, okay? And it's an exponential value, 4.22, okay? Because we only need two of those significant digits. 4.22 times 10 to the negative fourth, that's the moles of barium hydroxide, okay? Now, since you have just that part right there, okay, here's what we're going to do. We're going to now use that number to get the moles of what? Of that acid. So I'm going to take that 4.22 times 10 to the negative 4 moles of barium hydroxide, okay, times. Now, right here, okay, I'm going to go back up to my chemical reaction, okay, and I'm going to put right here the 2 moles of HCl over the 1 mole of barium hydroxide. There's an imaginary 1 right there. That's going to go on the bottom. I've got 2 moles of HCl on the very top, okay? Again, this is for my chemical reaction. So 2 moles of HCl, and on the very bottom, 1 mole of barium hydroxide. And now cross out your moles of barium hydroxide, and you're now going to multiply that times the 2. Okay? So you've got the 4.22 times 10 to the negative fourth power, okay, right here, times 2. And you get 8.44 times 10 to the negative fourth, okay? So 8.44 times 10 to the negative 4 moles of HCl. Now, what do you think you're gonna need to do? You got to now divide that by your what? Your volume that they gave you in the problem. So remember, if you forgot, here's your volume right here, okay? That 20.0 milliliters, and that was for the acid. This was the volume for the acid. Convert that to a liter, moving your decimal, okay? So you end up with 0.0200 liters, okay? That is your volume that you're going to put on the very bottom, okay? Now, what you're going to do, okay? You're going to put that on the very bottom, 0.0200 liters, and divide those two right there, okay? So divide that by 0.0200, and you end up with this as your molarity, 0.0422 m for HCl. So that is going to be your molarity for hydrochloric acid, okay? Right there. So that's the molarity of the solution, okay? So I know this appeared like it was a lot of steps. So I'm going to recap those steps again to make sure that you guys are good to go. Okay. It says again, yes, I do, Aaron. Yes, I do. The link is in my bio for private tutoring, and it is on Zoom, and I do record them, and I give the video to you if you request them. I do have a YouTube channel, Giselle, and it's Learn Chemistry with Professor TK the Chemist. And the link is also in my bio. So if you hit the button, it'll take you straight to my YouTube channel as well. And this right here, because I am live on YouTube, you guys are able to see this video back to go back and play it. Okay, so right here, let me go back and recap this problem again in case you guys were like, what in the world? If you see that the problem's dealing with titration, it says in a titration, 27.4 milliliters of 0.0154 molarity of barium hydroxide is added to a 20.0 milliliter sample of HCl solution of unknown concentration. What is the molarity of the acid solution? So that's the question that we need to solve. Now, even though they did not give you a balanced equation, you have to write this reaction out. Barium hydroxide reacted with HCl, hydrochloric acid, and it provided us with barium chloride and water. You have to balance this reaction. Now, we typically would use M1 times V1 equals M2 times V2. Yes, yes, yes. But in order to understand the formula that I wrote in yellow, you had to multiply what you do know that was given together. The A stands for acids and the B's stand for bases. They did give you the base information, which was the molarity and the volume. So what do? We multiplied those two together. Remember when I told you if it says the word of, okay? So this said of 27.4 milliliters of 0.0154 molarity. So that's why we multiplied those together. However, we had to make sure that our volume was in liters, not milliliters, because we would not have been able to cancel them out. When you're dealing with molarity, molarity is moles per liter. So we multiplied those two together, and we got 4.22 times 10 to the negative fourth moles of barium hydroxide. You then had to find, and using your mole to mole ratio, the moles of your HCl, because remember, they did not give that to us, okay? So in order to do that, you had to use the coefficients in front of HCl and the coefficients in front of barium hydroxide, okay? There's an imaginary 1 right there. That's what the 1 is for in front of barium hydroxide. So I use those coefficients in this step right here. And I got the 4.22 times 10 to the negative 4 times 2 moles over 1 mole, okay? Yes, Aaron, yes, by all means do, yes. But when you hit the link in my bio and you go to my channel, I'm not my channel, you go to my website, all the information will be there for you. It's like a survey of questions that you answer to let me know what you need help on. And then we'll actually go from there with the with how you would send the files. Yes. Yes, I don't mind doing that. Aaron, what are you working on right now? Okay, so now all you have to do is just take that 4.22 times 10 to negative 4 and multiply it times your 2 moles of HCl, because remember, we canceled out our moles of barium hydroxide, and you're now giving your moles of HCl divided by your volume. And remember, that volume, that 0.0200, that comes from what? The volume here for your acid, okay? Okay, I got you. I got you. Yes, yes. Go ahead and hit that link and we can get together. Yes. Oh, okay. Yeah. And I got a couple of videos on buffer solutions, so you can check them out on YouTube. And I think I have a few on TikTok. Yeah, I mean it's some I do so many different videos, but I do know that they're on TikTok and YouTube. Mm-hmm. So now, and this is all you have right here. Okay, you're welcome. You're welcome. Aaron, just so I'm clear, is this what you're working on? Let me switch the camera. I mean, switch the page right here. Let me see. Um, no, 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 not this, because you said buffers. Um, does any of this look familiar right here, Aaron? Like in terms of trying to find your moles and okay, yes. Then, yeah, let me know. Yeah, when you book your session, you send me everything you want me to go over, and we will answer every question that you need, including your quizzes and your homework. Yes, we will go over those. Yes. Okay, very good, very good. So guys, before we get out of here, let me tell you guys, again, for those of you all that don't know my schedule, I go live Monday through Thursday, 12 noon Eastern Standard Time. 12 noon Eastern Standard Time. So depending on where you're located, you may be able to catch me, during your lunchtime, or it may be breakfast time if you're on the West Coast. Okay. It may be breakfast time. Also, I do go live in the evening time, depending on my schedule now. My schedule, it varies each week. Okay, it varies each week, but I try to go live in the evening times on Monday, Tuesday, Wednesday, or Thursday, at least twice during the week, in the evening time. You do as well, Erin. Thank you. Thank you so much. So you guys, if you have questions like this of what we did during my tutoring session, by all means, let me know. If you got questions, go to my last video and just put your questions there so that I can kind of get to you and get your questions answered. Okay. So again, we'll continue this lesson on tomorrow. I give away 4 hours each week, Monday through Thursday at 12 noon. And then it varies in the evening time. So about 2 hours if I go live twice. So I give away free tutoring session during my lives. However, if you need more one-on-one, by all means, let me know. There's a link in my bio to help you guys along the way. Okay. And since it is a solar eclipse day, I just might take off a percentage of my tutoring sessions, but you got to book it today. So I'm going to go to my site to start reducing the price, and it's just only for today since it is a solar eclipse day. Okay. So I will be reducing my prices, but it's only for the next, you know, we got what, 12 hours or so left today. So I'm going to go through there right now and knock them down so that if any of you all need help, you can get some free tutoring, not free tutoring. Let me recap that. You'll get a reduced price of my tutoring sessions for today. Okay. So you guys have a wonderful, wonderful rest of your day. And I will see you guys tomorrow at 12 noon Eastern Standard Time. Take care.